Hello everyone. Glad to see all of you here. And just as always, before we will start with reviewing of your assignment, please let me know that you can hear me well, that you can see my screen, that everything is fine. And you can put some pluses in live streaming channel or even on YouTube. Maybe some reactions on my message in live streaming channel. And after that, we can start. So, okay, well, I can see that everything's fine with connection, with sound. So we can proceed. Okay, we have two things to do for today. We have to review your first assignment of Home Library Service series. You had to implement REST API without connection to real database, but you had to implement it the way that allows you to migrate it to real database usage, to easily containerize your application, and so on. Maybe you already seen next parts of assignment. So a quick reminder what you had to implement. You have several predefined entities or resources in your application. It's user, which represent surprise, surprise, which represents user. It's artist, track, album, and favorites. And they have some of them have connections using ID. So favorites are connected to artist, albums, and tracks. Track is connected to album and artist using ID, and album is connected to artist. So yeah. And you had some REST API operation, CRUD operation to implement that allows you to get all entities, get a specific entity by ID, create a new entity, update entity, or delete it, and put it to favorites. You had several limitations, like you cannot add to favorites non-existing entity. It should be added to database first. You had the requirement to put some validation and send to user bad request in case if request is invalid. And because your entities are connected to each other, you have to remove connected entity ID from related connected entity. For example, if you delete artist, then artist ID in albums and tracks become null. And this artist ID is deleted from favorites to establish database consistency. And just as always, you run your service using npm start. You can configure your port of application using .env file, just like you did in simple CRUD API assignment. And you should you had to implement correct Swagger UI. But in fact, it was enough to fix Open API file, but you could implement Swagger UI in addition to it. So yeah, that was your assignment, and we have solution to review. So let's firstly start from verification of correctness of application work, because we have a lot of integration tests, and if they are passing, then we can make assumptions that everything works correctly. Okay, firstly I have to create .env. I already cloned repository and installed dependencies to not waste our time. And our application is running on port 4000. And let's run npm tests. npm run test. Okay, I can see that all tests are passing, so we will not try to manually test every endpoint unless we will find something interesting to check manually. So we can make assumptions that application itself works correctly, and let's take a look at the code. Okay. Just as always, we have an entry point, and for Nest.js application, this is your main TS file. It's created by Nest.js CLI when you create an application. What we can see here. First of all, I remind you that recommended way to import core modules from Node.js is to use Node protocol. I already explained why it is a preferred way, and official Node.js documentation says that. So please don't use just pass or fs or I don't know, utils, http. It's better to use not prefix. Okay, we have asynchronous function bootstrap, which is run by this file, and what we can see here, we create a Nest.js application using Nest Factory. After that, to establish validation, we use validation pipe, which is provided by core Nest.js module. After that, we get passed to OpenAPI specification file, API YAML, read it, and we have a very fancy thing. We have a Swagger module. It's not included in, let's say, very basic Nest.js modules, but it's one of them. It's one of the modules that present in Nest.js ecosystem. It allows you to easily create a Swagger UI to make interactive check of your application. So we provide application with port, and we run it using uplist and API call. So everything works correctly here. Yeah, and bootstrap function should be asynchronous according to documentation, regardless of what happens there. So yeah, let's take a look at the modules, and let's start from the root module, because you can see that Nest Factory accepted to create application. So let's dive into it. Okay. Usually in Nest.js applications, app module doesn't have any specific logic. It just accepts all other modules to compose it together, and and because of this, we have connections between different modules. For example, all these modules can use providers specified in corresponding section. So nothing interesting here. Yeah, by the way, by default, application has this default controller, get hello. Yeah, we can get hello world, but this is not what we are interested in for now. Okay, so my proposal is to take a look at some of real modules. Let's check how users are created, because users don't have direct connections to other entities with IDs. So it's from my point of view most let's say dependency pure module, if it is correct to say so. So yeah, once again, let's take a look at the modules. It aggregates necessary controller services and providers. And let's take a look at user service, which is used by controller. So user service is a Nest.js provider, which has dedicated decorator for that, injectable. It means that it can be provided via dependency injection to other modules, and it accepts instance of database service to get information, to maybe get information, maybe write some information to our database. And yeah, just a quick reminder, it's in-memory database. We will see what was used by a student for this purpose. Okay, we can see that first method is exclude password, and yeah, it was your functional requirement that password should be omitted from response, and we have disabled linter for this. This code is completely correct from pure JavaScript perspective, because and probably even in some learning courses, this is recommended way to get object with all properties without some specific property. But yeah, ESLint, your linter will complain about it, because when you create a variable using the structure assignment, you create it in the scope and you don't use it. So yeah, ESLint complains that okay, probably you should use this variable or not define it otherwise. From my point of view, it would be better to use some general purpose JavaScript library like Lodash. It has amit method, which basically does the same thing. You can provide it with object and name or names of excluded properties, and it will return object without these properties, and no linter complaints. Because you were not obliged to avoid external dependencies in this assignment, you could add everything you need. Let's check, maybe we already have Lodash here. We do not have it. Let's install it. npm I Lodash, and let's use it here. Because from my point of view, it's better to fix linter complaints rather than omit it. Okay, import amit from Lodash. Probably it should work this way, because we can import amit declared. Let's check whether it will work by default. Okay, let's rerun our service. npm run start dev. Let's run our application in development mode and check that tests are passing. It means that a password is correctly excluded from response. Okay. Probably import of specific function should look different. To be honest, I didn't set it for some time ago, but when you are working with Lodash, it's a good practice to import only a specific function. Yeah, so if you need amit, usually Lodash has some kind of this import Lodash / amit, and you can import specific function. This is important when you are working with code size dependent platforms like Lambda function in AWS. It's better to have a lower bundle size, and by importing specific function you can reduce it. Okay, so exclude password works as expected. Previous version worked as expected just fine, but yeah, just in case, I can show you how to do it a little bit better. Okay, we have a method to create, which creates a new user and push it to a database. We have a problem with this code. Maybe you can tell me which one. I will wait for, let's say, 30 seconds for your response. You can write it in live stream channel. And yeah, we are taking into account some delay between you and me. Because in general it looks fine, but we have a problem with creation of new user object. Okay. 1, 2, 3, 4, 5, solved. I will explain to you. When you create a user, you should not use two separated API calls for getting created at and updated at timestamp, because well, it's it's obvious that when user is created, these timestamps should be equal. But these are two separated API calls and they can be a little bit different, which may lead to the problem because maybe you have some analytics. Okay, imagine we do not have this version thing that explicitly tells us about current user version. But some analytics or functionality for change detection may depend on difference between created at and updated at. And if some user has different timestamps, even by 1 millisecond, which is possible, yeah, I had such issue in real world project, in production project, because some guy said creation of entity like this, and we had flaky unit tests because of this, because it expected exactly the same timestamp for newly created objects in created at and updated at, and in some very rare cases it was different. So proper way to do it is to define variable current timestamp date now and reuse it in both places. Okay, good. We are using inbuilt Node.js function random UID instead of UID package, which is good because you don't need to install additional dependencies for what Node.js has out of the box. After that, this user is pushed to database, and then we return user with excluded password. Probably we could exclude password not here, maybe we can use it at database service level, but anyway it works correctly according to functional requirements. But this has some duplication because in all the places where you need to return user or multiple users, you have not to forget to exclude password. Probably having it in one place, like if database service could return users without password and this service didn't need to remove it manually, it would be better, because when you add new method, you may forget about removal of password, which can lead to serious security issue. Okay, so create method, we just checked it. Find all, just database users exclude password. Okay. Find one, we just find the user by ID. If we didn't find such user, we throw not found exception. Otherwise, we return this user with excluded password. Update. Firstly, we check that user exists in our database. After that, we find it. We check that okay, if user password is not equal to update password, old password. It's a bit confusing for me because it looks like I don't see hash in here. I don't see hash in here. So basically we are expected to compare hashes of passwords, not passwords itself, but we will see how it works later. So, okay. After updating of user, we refresh updated at timestamp, we increase version by 1, and after that we return updated user. Okay, looks correctly. Removal works using splice API call, which is really like multifunctional Swiss knife for working with arrays, because it can remove items from array, it can insert it into specific position, everything you need. It has a very rich API signature. You can read about it on MDN. So I I advise you to try to use it if you haven't used it before. because maybe you can try to do this operation using like filtering or some other suboptimal solutions. Splice is really better. Okay, so what happens here? We try to find user index, and after that we remove this item by this index. Simple as that. Okay, let's see how this service is used inside of controller. So controller is basically just a class in Node.js which has controller decoration decorator that accepts API endpoint pass. So we have a method that is handled by post to /user, and it's expected to return create a status code, not just OK. So it simply passes API call to user service. And we extract data from data transfer object using BOSIT decorator. So we have get method find all. This is just proxy to find all. We have get by ID. We use EasyUID validation here. And from my point of view, this is correct implementation because you should separate your functionality by layers according to REST principles. So if something is related to request validation, this is controller layer level of responsibility. Yeah, your service shouldn't check correctness of request. Probably it could be improved a little bit because this param thing, this is a decorator to extract pass parameter from URL. Probably we could create some custom decorator, or maybe there is some predefined decorator out of the box that checks that this parameter not only exists and tries to extract it, but also that performs validation and checks whether this is UID. But in general, we have validation. It happens at controller level, so I'm more than fine with that. Okay, we also have put request handler update, which also checks UID, which should check update password DTO properties, but probably it's done by class validator, and because of this using validation pipes. And yeah, it also simply passes API call to service after prior check of UID, and the same thing for removal of user. We only have different status code of response. Yeah, according to the assignment, you had to respond with no content status, and it doesn't differ. So in general, this is how it should look like. If we will have more complex logic, more specific things related to handling of requests, we can put it here, but yeah, we have just a dump controller that passes API calls to service, and service contains layer for business logic, which is correct. Okay, good. Let's take a look at user entity. We have types for user, for response. We have data transfer objects with proper decorators. Yeah, we check that some properties are strings, that they can be empty. Okay, probably no questions from my side to how users module works. Okay, let's take a look at database implementation. Database module accepts database services provider and exports it to for using with for using by other modules. Okay, what do we have here? We have specified properties for collections of users, artists, tracks, albums, and favorites, and And probably there is a lack of abstraction for this database service. What do I mean? Uh, Everywhere where we work with database service, we work directly with collections of corresponding entities. Like okay, you've seen that inside of user service to find users in database, we are working with users collection directly. For our simple application and for functional requirements, this is fine, but your code can mistakenly, I don't know, mutate or corrupt these objects. So probably better way to work with your database is not to expose your collections directly. Yeah, because we all know that objects are passed by link. So if you will get your user's collection somewhere in your code base, you can change it. You can even overwrite it if it's not set as constant. So many side effects. It would be better to expose only methods to work with your API. For example, I don't know, create user or push user to database, and external code should only work by API contract, not directly manipulating collection. So probably this is what could be improved. We have some methods here that satisfies this requirement about 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 uh, about when you remove some entity that has connections, you should nullify corresponding IDs in related entities. So we can see that, yeah, when we delete artist, we remove this artist, and after that we set artist ID to null for every related entity. Okay, same with deletion of album, same with deletion of track. Good. By the way, when you will connect real database, you will not have to do it manually because Postgres may handle it for you, but you will learn how to do it in corresponding assignment. Okay, so yeah, from functional perspective it works correctly, but it's insecure to expose collections directly. You should prefer API calls instead. Okay, let's take a look at albums. Module is pretty same. About service, we have methods for creation of album. Pretty same stuff. Random UID as ID, name, year, artist ID, and so on. Find all works pretty same. Find one works pretty same. Update also works pretty same. Okay. This DB delete album. Okay, from responsibility division perspective, this looks correctly because album service removes some album from database, and instead of manually deletion of related entities at album service here, we delegate it to database service, because if we have connections in our database, it's database responsibility to correctly clear it. You shouldn't do it manually in many different places, so this is good. Exists, we only check existence of some album. Okay. Let's take a look at the entity. Yeah, just type album and DTO. We have decorators. Year should be integer. Artist ID is optional. Update should have all the necessary fields. Okay, looks fine. Let's take a look at the artist service. Module is pretty same. Let's take a look at the service. Okay, we create a new object and push it to database. We find all artists and get it from database and return it. We try to find one artist and return it once again, update. Everything looks pretty same here. Okay, let's check tracks. Module also works with controller and service. Service has methods to create new track. Yeah, by the way, what is good in this code that we have this nullish calls operator instead of just using, I don't know, ternary operator or logical or. So yeah, this is a specific operator that returns right part of expression if left part is null or undefined, which allows you to correctly work with falsy values like empty string, 0, false, because if you get false, you do not always need to set null or undefined as a field value. Okay, so we create new track, push it to database, we get all tracks from database, find one the same way it was before, update works the same way it was before, and remove works pretty same. It only differs in what API calls on database level we perform. Probably if we would like to dive deeply into dry principle, we could create some abstractions that accepts necessary stuff that makes a difference between each entity, and take into account that find all, find one, and remove work and exist works. They work pretty same way. Maybe we could create some basic class for this, but it's really up to you, because when you should do such abstractions only if you are sure that your logic will not change for different entities, because it will be a pain in your ass if you if you will need different logic, but you will try to use these high level abstractions. So abstractions for abstractions is not the way we do our work. Create track.dto has necessary entities and corresponding decorators for validation. About entities, we use interface for track. Which is what is also good, that we have consistent usage of types versus interfaces. In general, they are, let's say, exchangeable. I mean, for most of the cases, you can use either type or interface keywords of TypeScript, but it's better to use either type or interface, not both. And from my point of view, type is, let's say, more powerful thing. So it's probably good that we use types everywhere. Okay, we took a look at how separated entities are created. Let's take a look at favorites. So favorites module accepts other entities module because we need to work with them. It accepts its own controller and service. Let's take a look at the service. So we have injected database service and artist albums and tracks service. Okay. First method is find all. We get find one. Okay, what we're trying to do here? We are trying find one by ID. To be honest, I don't get what happens here. Okay. We are iterating over favorites database, and for each ID from favorite database, we try to resolve it using artist service. For example, we have like IDs of artist 1 to 3, and we will have 3 API calls for to resolve these IDs. From my point of view, this solution is suboptimal because you make a lot of API calls to get your entities, because it can be a lot of them, and probably you should implement some methods inside of artist service to get multiple entities by IDs, because well, we can iterate over artist collections once to get for example 3 IDs instead of iterating it 3 times to get the same 3 IDs. Because imagine you have like, I don't know, 100 favorite artists, and you will have to iterate over artist collection 100 times. So it is not scalable. This solution is not scalable. And probably it's okay that you do promise all for these multiple API calls, but these API calls wrapped in promise all can be also wrapped in promise all. I mean, artists don't depend on albums and tracks, so probably more optimal solution would look like this. You should implement dedicated methods inside of each service, and you should do 3 iterations in parallel, one for artists, one for album, and one for tracks. And each iteration will resolve for you specified users, albums, and artists. It would reduce complexity of this algorithm significantly. Okay, we also have add track method. We check that track actually exists, and if this track is not added to favorites already, we push it to our favorites collection. We can remove track by checking whether it exists in our database. So if it exists, we remove it. Otherwise, we return not found. Same stuff for add album, remove album, and add artist, remove artist. Looks pretty simple, but a lot of duplication of code once again. So probably you could have one method which only is pointed to a collection it should use to resolve entities and check it. Okay. So let's check controller. So we have find all methods that handles get request to fefs endpoint, and from what I can see, it is consistent with how other modules work, because it has logic related to request, but for business logic we use favorites service. So we can add track with specific ID, we can delete it from favorites, and the same things for album and artist. Okay, looks fine. Let's check entities, favorites entities, favorites response. By the way, for responses you can also use data transfer objects. Probably it's a preferred way in Node.js. Instead of using just types and interfaces, you may sometimes use data transfer objects. But favorites response type is also fine. Okay, let me check whether we had to hash password, because probably it was mentioned somewhere. Maybe we had such requirement. for other assignment, because it is weird if I didn't add it. Okay, probably it's my bad that I missed it, but anyway, in real world you should never store your user's password in database, because database may be exposed, it may be stolen for some reason, and in case if you will store passwords in your database, your users would be compromised. If you store hash without knowing of secret for your hash creation, and even with it, it would be difficult to restore your password. So it's more safer thing. And probably we should check that our Swagger UI works correctly. Okay, localhost 4000. We can copy it. Okay, we have hello world from app controller, and let's check doc endpoint. Okay, we can see that our endpoints seems to be working correctly. Okay, let's try it out. 1, 2, 3, 4, 5, and the same password. Okay, we created our user. Let's try to get it by ID. Okay, we get our user without password. Let's try to send invalid UID. We get bad request. Okay, so it seems that Swagger UI works correctly as well. Probably for this assignment, let's check whether we have something else that we didn't check. Tests, we are not interested in it. API YAML contains YAML specification for OpenAPI. Everything else we checked it. Let's check README. Okay, we have this brief description of service, its features, how to install, how to run our application. Okay, create.ten file. Testing. Endpoints. Probably you could have more specific description, because it doesn't tell us in which cases we have these responses. Okay, so maybe you could reuse description from assignment. It's full enough. Okay, because we have description for each case, and you can just copy it and insert into your README for a service. Okay, in general, I have concerns about how database service is implemented, and also probably we could avoid some duplication and use dedicated decorators to do our job. What was good, that all functional requirements are implemented, service works correctly. We also have consistent modules architecture. You can see that same things are done the same way across different modules. We also have asynchronous methods. They are synchronous, really, because it works with just array, but it will help you to replace your mock database with a real one, because API calls to real database would be different. Okay, so let's check your next assignment. Or maybe if you have some questions related to REST service, you can leave them in a live streaming channel. I will check for your questions after I will explain your new assignment. So what you should do next? You have, let's say, a skeleton of your service. It works, it has all necessary endpoints, it even has asynchronous signature, it works on Node.js. What you should do next? You should implement two improvements to your service. First of all, you should connect it to real database. For database, we use Postgres. We use specifically Postgres, and you should use ORM tool. You can use TypeORM or Prisma. What is preferable for you? They have a little bit different code styles, but in general, both of them has all the necessary functionality. Also, you can use some secrets to connect to your database. And just as always, we never hardcode secrets. We only put it into .env file, which should be emitted by Git. Probably in template of this service, you already had it predefined, but just in case, if you create your project from scratch, never forget to add .env file to git ignore. And also, your Postgres database should run inside of a Docker container. Why are we doing that? If you learned some information about Docker, you know that it provides universal, not universal, unified functionality to run your code on different platforms, because container has all the necessary system level dependencies, and your Docker image would run the same way on Windows, Linux, Mac OS, and so on. So it allows you to have a more reliable database connection than if you would install it on each system different way. So functional requirements are not changed. You should use your integration test to verify that your service works correctly. The only difference is that you should remove this mock database from your service and replace it connection to real database. And Nest.js, let me show you one hint from documentation, because we had some stuff for at least TypeORM. GraphQL, microservices deployment, open API recipes. Let's see, TypeORM. Yeah, we have this techniques database documentation page, which contains information on how to use TypeORM with Nest.js. We already have decorators for this. We have Nest.js TypeORM module, which allows you to connect your TypeORM to your project painlessly. And you can see that creates are provided on initialization of TypeORM module. It's very convenient, it's very handy. So if you will decide to work with TypeORM, I encourage you to use this Nest.js TypeORM library. Okay, what should we do in scope of containerization? You are expected to use Docker for this purpose. You can use Docker desktop, because if I am not mistaken, you should double check it in actual Docker documentation, but if I'm not mistaken, for learning purposes or small teams, Docker desktop was eligible and was free. So you should create a Docker ignore file and list all files that should be ignored by Docker on building your image and container. You should create a Docker file that you will use to build Postgres database container, and you should create separated Docker file for building of your application container. We have two Docker containers, and they are dependent one on each other, yes, because our application service depends on database service. because our application cannot work without database. So we need some orchestration for these multiple containers, and maybe you heard about stuff like Fargate in AWS, maybe you heard about Kubernetes, maybe you heard about Docker Swarm, but these solutions are very complex for our use case. We don't need this complexity, overhead, and scalability for our case. We simply need to establish connection between two Docker containers. So we have awesome tool named Docker Compose just for these simple cases. So you should use it to run your multi-container application in one script. You should also implement scanning of your images for security vulnerabilities. Docker has awesome functionality with SNYK scanning. And also you should push your images to your personal repository on Docker Hub. Yeah, we have, just like for code, we have GitHub, we have Docker Hub for Docker images to reuse it. Okay, what about implementation details? Description of assignment is pretty generic, but you have more detailed instructions in scoring. First of all, I recommend you to start with containerization, because you will need database to work with it. So probably you should do this part first. So README should still contain detailed instruction how to run your application, and please make them very accurate and descriptive, because our students, they may have different laptops, we may run our code on different platforms, and they should know exactly how to run your applications, because this assignment is the most difficult one from point of view how to run this application, how to run other student application during check. So we have many false alarms, like nothing works correctly because user misconfigured Docker, or instructions were unclear. So please pay attention to this. Also, you should establish a connection between your containers using Docker Compose with user-defined bridge. Not default one, but user-defined. Also, a container should restart after crash. Application should restart if you make changes inside of SRC folder. So, I mean, you are working with your code locally, and you have a running container with your application, and when you when you make some changes into your SRC folder in your code, you should have your application inside of container restarting. You can use bind mounts for this purpose. And also, database files and logs should be stored inside of Docker volumes instead of just container. Why are we doing this? Because if our container is removed or restarting, if you store all the data inside of this container, it will be destroyed. But this is not something we want to our database. It would be terrible service if our database was completely wiped on each restart. So we should store it inside of volumes to preserve it. Also for database assignment, we have a score for passing tests, and how do we verify that data for specific entities is stored inside of Postgres? You should check it in code, plus you should run unit tests. So if you see that everything is stored inside of database and tests are passing, you can make assumptions that everything works correctly. We have some advanced scope for these functionalities. First of all, you should try to reduce size of your Docker image as much as possible. It can be achieved by several techniques. First of all, you should build your Docker file. You should build your Docker image using Docker file by setting layers in proper order. You should learn how your Docker file content is transformed into Docker image, because order of your commands inside of Docker file really matters, and it really affects how often and how deeply your Docker image would be updated when you change your application, and it affects your Docker image size. Also, you should implement a script, npm script for vulnerability scanning, some free solutions that doesn't require to attach your credit card. And also, your build image should be pushed to Docker Hub. What about database and ORM connections? You can use a technique, at least during your development, initial development, like synchronization. What it means? You create your database models. You describe all your entities like as database modules in your code base, and you can provide option like sync true to your ORM to make your ORM create database schema based on your models for you. But this is not very good way, because on changes to your models you can corrupt your database, you can lose some data. So for production we should use a thing named migrations. How it works? It creates your schema in reliable way. Usually this is migrations contains two parts, like up and down. So up makes changes to your database, and down reverts these changes to your database. And by running specific migration, you can achieve migration of your data from between different database schema versions, and you can avoid losing your data. So if you will use migrations, you will get extra points. Also, as I mentioned, we never store. I will mention it again and again. We are never storing sensitive information inside of code base. So variables used for connection to database are stored in .env. Also, to establish connections between entities, like you have connections between album and artist, you have connections between favorites and corresponding entities, and so on. So we have in SQL we have things named relations, one-to-one, many-to-one, many-to-many. You heard about it, I'm pretty sure. So you should use type ORM decorators or Prisma relations to establish those connections. And also, if local Postgres installation is not required during task check, I mean, if Postgres database is running inside of a container, you will get extra points. So you can still try to implement database part of assignment if Docker is very hard for you, but you will not get a score for Docker part and for this point. Okay. You have some specific forfeits for this assignment. For example, you should use a specific image for building of your Postgres and service container. I mean, you can build your application from scratch from very generic images, like you can use Ubuntu as base image, for example. But if you will search Docker Hub, you will see that you can find a more specific image which already has everything you need for running your Postgres or Node.js, but it has less dependencies and has less size. So you should use it. Also, if Postgres container is not configured as dependency for application container, you will also get forfeit, because as I mentioned, our application depends on database. Minus 10 points for each failing test with npm test, because tests should pass. You only change the source of your data, but not logic. Docker compose.yaml should also get variables from .env file. You should not hardcode some sensitive data there, because Docker compose is part of infrastructure, and it's also committed to your repository, and you should not expose any secrets this way. Our standard forfeit for breaking deadline, our standard forfeits for no pull request, no pull request description, or it is incorrect, no separate development branch, less than 3 commits in development branch, and minus 10 point for each linter error. Run on local config and ts config. Okay, probably that's it about all of your assignments. Maybe you have some questions about Docker and or connection to database. If yes, you can paste those questions to corresponding tasks channels later or to live stream channel now. I will wait a little bit, and if you don't have questions right now, which is just fine, because you should check how to connect database, some SQL basics, some Docker basics, and containerization concepts. Maybe you will have some questions later. It's fine. Okay, good. No questions for now, so good luck with connection to database. Good luck with SQL. It will be funny, especially for favorites part, but I think you will learn something. Okay, good. So thank you for joining and have a nice evening. Bye bye.